There is a planet 500 million miles away that has been watching Earth for 4 billion years. You already know what it does for us. We covered it in a previous video. Every way, Jupiter has saved life on this planet. Deflecting comets, absorbing impacts, standing between Earth and the chaos of deep space. Jupiter, the shield. Jupiter, the protector. But there's a version of that story nobody tells. Because the same gravitational force that deflects rocks away from Earth has, on multiple occasions, aimed them directly at us. The same giant that stabilized our solar system once migrated through it like a wrecking ball, resetting everything, including the odds of life surviving at all. And the same planet that may have absorbed objects headed inward may also have helped send the rock that ended the dinosaurs. So here is the real question, and hold it for the entire video. Is Jupiter the reason life exists on Earth, or the reason it nearly didn't? The answer isn't what you think, and it's coming in the last chapter. For decades, the story was simple. Jupiter is big. Jupiter's gravity catches incoming objects. Earth is safer because Jupiter is there. Then, a paper landed with a title that stopped the astronomy community cold. Jupiter as a sniper, rather than a shield. Jupiter's gravity doesn't just catch things, it redirects them. Picture a planet the size of 318 Earths sitting in the outer solar system like a massive gravitational roundabout. Objects that come near don't always get absorbed. Sometimes they get slingshot. And the path of that slingshot often points directly inward, toward Mars, toward Venus, toward Earth. Simulations now show Jupiter is just as likely to send a comet toward Earth as to deflect it away. The shield works both ways. The asteroid belt, that ring of rocky debris between Mars and Jupiter, exists partly because Jupiter's gravity kept it from forming into a planet. But that same gravity never stopped stirring it. Jupiter has resonance zones in the belt, where its gravitational pull periodically tugs any drifting rock onto a new orbit, sometimes toward Earth. This isn't theory. We have watched it happen in real time. But to understand where this truly breaks everything you thought you knew, we need to go back 4.5 billion years. Because that's when Jupiter did something astronomers once thought was impossible. 4.5 billion years ago, Jupiter moved. Not a little. Not a slow drift. Jupiter crossed the young solar system like a wrecking ball, all the way inward to where Mars sits today. Then Saturn locked into gravitational resonance behind it, and together they reversed course, migrating back outward to roughly where they are now. In that journey, and the return, Jupiter crossed through the asteroid belt twice. Everything in its path changed forever. A region that should have become a planet was left depleted, scrambled, scattered. And what Jupiter did next may have been even worse. Around 4 billion years ago, the solar system entered a period scientists call the Late Heavy Bombardment. Imagine the inner solar system, including Earth, subjected to a relentless rain of asteroids and comets for 300 million years straight. The Moon's oldest craters, the ones visible to the naked eye on a clear night, are the scars. What caused it? The leading model points directly at Jupiter. Its gravitational interactions with Saturn sent Uranus and Neptune scattering outward. Those planets hit the Kuiper Belt, the vast reservoir of icy bodies beyond Neptune, and triggered a cascade. Waves of debris fell inward, straight at Earth, for 300 million years. The planet supposed to protect us may have been the reason Earth needed protecting in the first place. If that just rearranged something in your head, you already know what the like button is there for. In 1993, astronomers discovered a comet already captured by Jupiter's gravity, being torn apart into 21 fragments stretched into a glittering chain of ice and rock. And it was heading back in. From July 16th to July 22nd, 1994, the world watched in real time as each fragment slammed into Jupiter's southern hemisphere. Fragment G, the largest, hit at 60 kilometers per second. The energy released was equivalent to 6 million megatons of TNT. To put that in perspective, every nuclear weapon ever built by humanity could have detonated at once, and still wouldn't come close. The scar left in Jupiter's atmosphere was wider than our entire planet. 21 impacts, 6 days, the most energetic collision ever observed by human eyes. Here's what that event actually proved. Jupiter catches things, and that is genuinely protective. But researchers running simulations afterward asked a harder question. What happens to comets that pass near Jupiter and don't get captured? The answer was stark. Many get redirected. Orbits bent toward the inner solar system, new trajectories pointing at Earth. For every Shoemaker Levy 9 Jupiter swallows, there are others it launches. And one of those launches may have changed everything. Where are you watching from? Drop your city in the comments. I want to know how many of you live somewhere that exists because of what I'm about to tell you. 66 million years ago, a rock roughly 10 kilometers across hit what is now the Yucatan Peninsula. The energy released was equivalent to 100 million megatons of TNT. It triggered firestorms, a global winter that lasted years, and the extinction of 75% of all species on Earth, including every non-avian dinosaur alive at the time. Where did that rock come from? A 2021 Harvard study introduced a model pointing the origin toward the distant Oort cloud, the spherical shell of icy objects at the outermost edge of the solar system. According to that model, Jupiter's tidal forces occasionally pull long-period comets inward, fragmenting them and scattering debris into Earth-crossing orbits. The study suggested a significant fraction of Earth's largest historical impacts may have originated this way. Other researchers argue the impactor was a carbonaceous asteroid from the outer belt, destabilized, again, by Jupiter's gravitational resonances. The debate is active. The science is not settled. But either way, Jupiter's fingerprints appear on the trajectory. If that impact doesn't happen, the dominant life form on Earth today is almost certainly still a reptile. Primates likely never develop. You exist right now because of a chain of events that runs through Jupiter's gravity. The chain runs both ways. But here's where it gets even stranger. What scientists discovered next completely changed the SHIELD story. Scientists have run simulations of our solar system without Jupiter, and in some of them, Earth gets hit less often, not more. Less. In those models, removing Jupiter actually reduces the number of short-period impactors that cross Earth's orbit. The reason is the same gravitational influence that deflects long-range threats also stirs up the nearby asteroid belt, nudging rocks into Earth-crossing paths that wouldn't exist without it. Here is the current state of the science. Stated plainly, Jupiter's influence on long-period comets, the largest and most dangerous class of impactors, is probably protective. The outer planets tend to deflect Oort cloud objects before they penetrate deep into the inner solar system. The SHIELD argument holds there. But for short-period comets and asteroids, the objects closer to the Sun, the ones we actively track, Jupiter's role reverses. Simulations show it is as likely to direct these objects toward Earth as away. Same planet, same gravity. Two completely different outcomes depending on which object you're measuring. The solar system is not a stable machine. It is a dynamic gravitational system in constant motion, in which the position of every planet affects every other. Jupiter, the most massive of them all, is not a fixed shield sitting at the edge of the system. It is an active force, sometimes protecting, sometimes aiming, sometimes across deep geological time, doing both at once. Now we're finally ready to answer the question from the beginning. Is Jupiter the reason life exists on Earth, or the reason it nearly didn't? Both. And that's not a diplomatic dodge. It's the actual physics. 4 billion years ago, Jupiter's migration may have scattered water-rich asteroids inward, eventually giving Earth its oceans. That same migration may have triggered the Late Heavy Bombardment that nearly sterilized the planet. In 1994, Jupiter absorbed 21 cometary fragments that might otherwise have destabilized orbits further inward. That same gravity, in other trajectories, sends objects toward us. 66 million years ago, Jupiter may have helped send the impactor that ended the age of dinosaurs. That same impact made room for the mammals that eventually became you. The dark side isn't separate from the shield. It's built into it. Every deflection has a mirror. Every capture has a launch. Every extinction has, somewhere in the long chain of consequences, an emergence. The thought to leave with, the planet that may have nearly prevented life on Earth, is also the reason life survived long enough to look up and find it. The universe doesn't guarantee a protector. We just happen to have one that plays both roles, and it hasn't finished yet. Subscribe, because this solar system is still moving.